Okay, for section P5, we're going to talk about solving equations graphically to start out with. And I've mentioned a couple times already about the ACT test and you having a graphing calculator and it being a multiple choice test. And we've studied some types of equations so far in this class, like say 3x plus 4 equals 4x minus 9. Okay. We learned the algebra that it takes to solve that in algebra class, and we relearned it again in this class as well. Okay. We know that if we get the x's together and then we add 9 to both sides using our properties that we've learned, we get x equals 13. And we also know that that's checkable. We can plug 13 into both sides of the sentence and make sure that we have an equality. If we don't, then something's wrong with our answer. Okay, but if we do that, we get 39 plus 4, that's 43. And if we do 59, 4 times 13 is 52, and 52 minus 9 is also 43. So we can check that to make sure it's right. Now, one of the things that we also want to be able to deal with, though, is that just for argument's sake, let's say that on the ACT test that we completely forgot how to solve linear equations. Okay? If we have a graphing calculator, do we really need to be able to use the algebra to solve this? Okay? Don't have to, because your calculator will show you the answer if you try to look at the bigger picture. Okay? Because all we're asking for in this equation, this original equation, is recognizing that this is a line and this is a line. We want to know when these two lines are equal. In other words, when do they graphically intersect? Okay? So, if we were to take our calculator and put those two equations in there and see what the picture looks like. We have our one line, and there's our other line. And you'll notice that we can't see an intersection in that screen because the window is not going to give it to us. We know that they do meet, though, because they have different slopes. Okay. We think that the answer is 13 here, but ultimately we can see that they're getting closer together as we move up, so we'd want to make that window. We hit our window here. We know that the answer is 13, so I'm going to make it, say, go to 20 instead. And then up, I'm going to make it go to 60. Okay. And again, you can experiment with your window here and so you see an intersection point, hopefully. Again, there's our first line, and there's our second line, and now we do in fact see an intersection point. So if we just do our calc button, which is above your trace, second calc, intersect, and then move the cursor over by the intersection point and hit enter 3 times, we can see what the answer is, 13, and the y-coordinate of that point is 43. Okay, however, though, do we really want to know anything about a y here in this case? Okay, all we're after here is what x will make this sentence true. Okay. All right. One other way that we could have solved that sentence with the graphing calculator, okay, is we could have put everything on the same side. Okay. So let me do that. If we did 3x plus 4 equals 4x minus 9, and we said minus 3x and minus 3x and minus 4 minus 4. We would have had x minus 13 over here. Okay. And with that said, if we follow that procedure with putting everything on the same side, having 0 on the other side, okay, now a bigger picture, all we're asking for is when does this, we know it's still a line, when does this line equal 0? Okay, and graphically, we're asking in this equation is when does this line cross the x-axis? That's all that is, isn't it? Because what is 0? 0 is the line y equals 0, which is the x-axis. When do these two meet? So if I were to do it with that approach, okay, which I can certainly do, x minus 13 here, and I'm going to go back to my standard window, zoom 6. Okay, once again, we can't see it because we don't have 13 on our list. So if we make our window go over to, let's say, 15, should be able to see the intersection point between it and the x-axis now. Okay, and again, that's all we're after is that point where this line crosses the x-axis. That's the solution to this equation. And the other command that we have in our calc menu is the 0 command. Okay, the 0 is the value that will make the equation equal to 0. Okay, we're looking for that value. Okay, the 0 is also graphically the x-intercept. Okay, keeping in mind that some equations, nonlinear equations, might have more than one x-intercept, which we'll look at in a minute. But to use the command, the technique is once you hit that 0 command, you need to move the cursor over by the intersection point. And remember on the bottom here, it tells you where you're at any given point in time. We can't see it on the screen because notice it's down at -8. We can kind of see it starting to come into the screen. But if we move that over closer to the intersection point, and once again we hit enter 3 times, but when we do the 0 command, we have to make sure the cursor's in the right position for us to do it. So notice it's asking for a left bound. Okay, we need to be left of the intersection point. And right now we are left of the intersection point, so we can hit enter. But then it's asking for a right bound. So we go to the right side of the intersection point and hit enter. And then it's asking us for a guess. And for the guess, you just want to move the cursor to as close to the intersection point as you can get. And when we do that, we get 13-0, of course, which we already knew that was the answer, but we can do that graphically. So once again, what I'm illustrating here is that in general, we've done it with something that we know how to do algebraically because we've done it, lots and lots of times. So hopefully, when it comes to ACT tests, we will know how to do this. Okay, but if we don't, okay, and we have this in our hand, do we really need to? No. So translating that to a more difficult equation, what if we have an equation that has cubes or squares or square roots or sine or cosine, something like that? Okay, is the process of using the graphing calculator to find the answer any different? So like I said, if there's an equation solving problem on the ACT test, is there any good reason to ever get it wrong? Especially multiple choice with the graphing calculator. Okay? Because if you sit there and think for 10 minutes, oh man, it's a quadratic equation, I don't remember how to do that. Okay? You don't need to remember how to do it, okay, on that test. Okay? Now on the test for me, when I see your work, are you going to need to be able to do it? Yes. Okay? But when you're taking that test, okay, you don't need to show any work. All they want is your A, B, C, D. Okay? So make sure you use the calculator to your advantage. Okay? So with that said, let's go ahead and take a look at another equation. Okay? And we're going to primarily focus on quadratic equations today. Okay? We're going to look at 3 different techniques to solve quadratic equations, and the one is the graphing approach, where we're asked for when does this equal 0. So again, bigger picture, we know that this is a parabola from our past experience. So we want to know when does this parabola equal 0. Okay, in other words, when does it cross the x-axis? Okay? And knowing what we know about parabolas and their shapes, okay, does there have to be an answer for this question? Okay. There doesn't have to be a real answer. Okay? We know that there could be imaginary answers. We'll deal with that in P6. But ultimately, okay, we need to see if we can find x-intercepts if we're going to do this with a graphic approach. Okay? So let's go ahead and put that into our calculator. 2x squared minus 3x minus 2. And we'll go our zoom 6. And we can see in this particular case, we do happen to have 2 intersection points with the x-axis. So I'm going to need to do that process twice, but let's go ahead and figure out what they are. We'll do the calc menu. We're going to do the 0 command. And there's my intersection point. I'm going to deal with the first intersection point on the left. Okay, I need to be left of it. Okay, notice that to be left of it, we need to be above it when the curve is going down. Okay, so left and above correspond with each other when the curve's going down. So we'll hit enter here, move it over to the right, which is below it in this case. Hit enter, go back up to the center and hit enter. And there's one of our intersection points, -0.5. Okay, we will write that as a fraction, of course. So there's one of our answers. And I want to also indicate here that this is important for our solution sets when we answer this question, that there's 2 answers here. They need to be connected with or, okay, not and. So the 2 answers are -1/2 or something else. So the something else we'll look at next. So starting over once again, calc menu, 0 command, move it over by the other intersection point this time. We need to be left of it, so that would be below in this case because the curve's going up. Right of it, okay. Enter, back to the middle, enter, and this time we get 2. Okay. And so therefore our 2 solutions here are -1/2 and 2. We can also check that just like we can check a linear equation by plugging a -1/2 in and a 2 in and making sure they both make the sentence true. Okay. You can do that with your graphing calculator. Remember also if you have that in y equals, which you already did if you graphed it. if you go table set, which is above your window button, okay, I have my table set on ask. I would put it on that, and that's good. Okay. And that way I can type in my negative 1/2. Oops, negative 1/2, not 0.1/2. So negative 1/2. I'm going to type that in there, and I get 0. Is that a good sign? I want to get 0. I want to make sure that putting a negative 1/2 in gives me 0. And if I put a 2 in, that also gives me 0. So what does that tell me about these two answers? We're good to go. Okay. Questions on anything about the graphing technique? We're going to have some work time in just a minute, so if there's any issues you're having with your calculator in terms of it not working for some reason, okay, we can get those answered too. Okay. All right. The second technique is going to be using the zero factor property. Okay, what the zero factor property tells us is that if we have two things that are multiplied and they equal 0, then one of those two things has to be 0. Okay, this accounts for it could be both equal 0 too, but ultimately if A, B equals 0, then A equals 0 or B equals 0. And what we're going to use that for is that same equation. Okay, we're going to solve this by factoring. Okay, we learned in algebra and algebra 2 how to factor quadratic equations. Okay, and however you learned it is fine. Okay, if you learned it with the trial and error method, that's okay. If you learned it with another method, that's fine. But one of the things that's expected in pre-calc is that we can factor that, okay, within 5 seconds or less. Okay, so once again, if that's another skill that you know that you're going to have trouble with, okay, you need to let me know that, and we can make worksheets and practice and make sure that we can factor in our sleep. Got it? So got to be able to do that very quickly. That can't take us a bunch of time to figure that out. Okay. So more importantly, once we get done with the factoring part, then we have A, B, if you will, and if A and B multiplied equals 0, then one of those two needs to be equal to 0. So the technique that we learned and we're relearning now is that we set each of those factors equal to 0 and then solve the two linear equations that result. So if we did that for this one, and we divided by 2, and this one we just have to add 3. Whoops, not 3, sorry. 2. There we go. Sorry. So if we add 2, or add 2 to both sides, we're going to get x equals 2, which once again gives us the same two answers as we got out of the graphing calculator. Okay. And ultimately, which approach is better? Okay. They both give us the same answer. One problem that we'd have with the graphing approach, though, is if these answers weren't nice answers, we'd have a difficult time getting an exact answer. We'd have to round sometimes with a graphical approach. Okay. Any questions so far? All right, so part of our work today is going to be dealing with this technique number 2, where we factor